Hi, this is third question of TIFR 2025 Maths PhD at CAM exam. Question is from linear algebra. We have given the polynomial px is equals to x cube minus x square minus x plus 1. Consider the following statement. We have to check whether which one is correct. First statement says that if t from R3 to R3 is a linear transformation and p of t is 0, then t is invertible. So t is invertible. When we say that t is invertible or any matrix is invertible, any non-singular matrix is invertible, it means that its determinant is non-zero. It means that none of its eigenvalue is 0. So p of t is 0. It means that p of t annihilates the polynomial. It means that let me write it. We have given p of x is equals to x cube minus x square minus x plus 1, and it says that t is from R3 to R3, means t is a 3 cross 3 matrix. Okay, and p of t is equals to 0. It means that t annihilates the polynomial p. So p of t is equals to t cube minus t square minus t plus 1 is equals to 0. So option 1 is asking whether t is invertible or not. So t is invertible if none of its eigenvalue is 0. So eigenvalue, we will find the roots of this polynomial. If 0 is the root of this polynomial, it means that my t is a singular matrix. It means that t is not invertible. So we will find the root of this polynomial, means eigenvalue of this polynomial. What is the eigenvalue? So I am simplifying this polynomial. T square t minus 1 I have taken common from this, so we get t minus 1. So it is t minus 1, t square minus 1. So it is t minus 1, t plus 1. Or we can write it t is equals to 1, 1 and minus 1. So we can clearly see that none of its eigenvalue is 0. Hence t is invertible. When t is not invertible, if I get a 0, 0 is root of this polynomial. It means that t is a 3 cross 3 matrix with determinant 0. Means what is the determinant? Determinant is the product of all eigenvalue. If 0 is an eigenvalue of t of this matrix, then t cannot be invertible. So here we have all the eigenvalues non-zero. It means that t is invertible. Hence option 1 is correct. Okay, for option 2, if t from R3 to R3 is a linear transformation and p of t is 0, then t is diagonalizable. So it is asking about diagonalizability. When we say that a matrix is diagonalizable, if the minimal polynomial of that matrix can be written as the product of linear factor. So t is diagonalizable. Let me write here. T is diagonalizable or not. How we can find it? P of t is 0. It means t cube minus p of t. T cube minus t square minus t plus 1 is 0. So, or we can write it as t minus 1, t plus 1 is equals to 0. So, what is the possible eigenvalue for this characteristic polynomial? Since t is a 3 cross 3 matrix, so its characteristic polynomial is a 3-degree polynomial. So since t annihilate this polynomial, So possible minimal polynomial can be p of x, or p of x contains the factor of minimal polynomial. So here let me write it. Possibility of mini possibilities of minimal polynomial. It can be x minus m tx. It can be x minus 1 whole square x plus 1. Also, since it is an annihilating polynomial, whole is equals to 0, it means t annihilates this polynomial px, so px can be minimal polynomial. There is no more information about minimal polynomial or other details, so there is a possibility that p of x can be the minimal polynomial, or it can be x minus 1 x plus 1 also, because minimal polynomial divides the characteristic polynomial, so it can be any one of its factor also. So we have these four possibilities of minimal polynomial. So we don't know what is the minimal polynomial uh, of this matrix. So if if the minimal polynomial is this p of x, then it cannot be diagonalizable, because a matrix is diagonalizable if and only if its minimal polynomial is linear factor, is product of linear factor. So if minimal polynomial is any one of these, then only this t is diagonalizable, but we don't have any information about minimal polynomial, that which one can be the minimal polynomial. So it can be px itself. So if px itself is the minimal polynomial, from the characteristic polynomial only we cannot conclude that t is diagonalizable or not. I can show you by taking some examples. Let's say I have a matrix T1 having the same eigenvalue as T. It has 1 0 0 0 1 0 0 0 minus 1. So T1 has eigenvalue 1 1 and minus 1, and my T also have eigenvalue 1 1 and minus 1, and its characteristic polynomial is characteristic polynomial of T1 is x minus 1 whole square x plus 1, and its minimal polynomial is m T1x is x minus 1 and x plus 1. Okay, so here my minimal polynomial is the linear product of linear factor, so T1 is diagonalizable. I am taking another matrix T2 where 1 0 0 1 1 0 0 1 0 0 0 minus 1. So its characteristic polynomial is x minus 1 whole square x plus 1. Both T1 and T2 both have the same characteristic polynomial, but T2 have different minimal polynomials, since it has eigenvalue 1 1 and minus 1, but algebraic multiplicity of 1 is 2 here. Means the eigenvector corresponding to 1 is we will get one linearly independent eigenvector, only one linearly independent eigenvector with respect to eigenvalue 1 here. So we will get the minimal polynomial same as the characteristic polynomial, you can check. So here in this case minimal polynomial and characteristic polynomial both are same, and this is not the product of linear factor, so T2 is not diagonalizable, not diagonalizable. So we can clearly say see that whether p of t is 0 means if t annihilates this polynomial, means by knowing the characteristic polynomial only we cannot conclude that t is always be diagonalizable or not. T can be diagonalizable or t might not be diagonalizable. So this option is correct, but we cannot say that this is always true. So this is not always true, so only option 1 is correct. I am showing the whole solution of